All right, this video is going to be on how to solve rational inequalities. And as far as topics go, it made a little bit more sense to do it last unit, but it's easier to learn this unit after you've learned all about graphing. So I'm going to go ahead and go through a couple examples, and then hopefully we'll start to pick up on the different things that make these problems similar so we can kind of know how they work. So the first example is we're going to have the irrational expression x minus 3 times x plus 2 divided by x minus 1. And this expression is less than 0. So as far as this problem goes, this is pretty simple because it's written in a way where we can see exactly what's going on. So if you guys recall, any factors that cancel would represent an x-coordinate of a whole. Factors that don't cancel that are left over on the top represent x-intercepts. Factors that don't cancel that are left on the bottom represent vertical asymptotes. So we know that any factor that shows up in the bottom is going to be a value that you cannot equal, and any value that we have on the top is going to equal 0 exactly. So that's going to come into play in some of the problems where we can have it and some of the problems where we can't. So if we look at this problem, we know for sure that x cannot equal 1. All right? We know here that we have x-intercepts at x equals 3 and x equals negative 2. And the symbol right here tells us that we should not include our x-intercepts because our inequality doesn't say that it can equal 0. So we're going to say cannot equal 0. So exclude x-intercepts. Okay, so anytime we are solving something and we have factors and we have an inequality sign, we always do that number chart or that sign chart that we did before. So positive 1 for sure is excluded no matter what the inequality says. And then for these two, because the inequality says less than 0 and not less than or equal to 0, then that means we cannot have 3. I made a lopsided number line. And we cannot have negative 2. There we go. So what we're going to do now is we're going to test the numbers in this interval, here, here, and here, and we just want to see if it would be a positive or a negative. So a number to the left of negative 2 would be negative 3. And if I test negative 3, I get negative 3 minus 3, which is a negative. Negative 3 plus 2 is also a negative. And negative 3 minus 1 is also a negative. So if I think about this, a negative times a negative is positive. A positive divided by a negative is negative. So this interval over here would be a negative interval. A number between negative 2 and 1 would be like 0. So if I try 0, 0 minus 3 is negative, 0 plus 2 is positive, and 0 minus 1 is negative. And here we have this negative and this negative would cancel each other out, and so the result here would be a positive. So between negative 2 and 1, any value that we plug in here into the x would make this inequality positive. Next, I'll choose a number between 1 and 3, like 2. 2 would work. So if I plug in 2, 2 minus 3 is a negative. 2 plus 2 is a positive. 2 minus 1 is a positive. And so I would get a negative on top. A negative divided by a positive is a negative. And then last, I have to choose a number to the right of 3. So 4 minus 3 is positive. 4 plus 2 is positive, 4 minus 1 is positive, and so overall that would give me a positive number. So now I have my sign chart, and now I have to think about which parts of the sign chart I want to keep. I call it a sign chart because it tells me the signs of my numbers. So when I evaluate this, if I plug in a number over here, this is going to be negative. If I plug a number in here, this is going to be positive. So I want to choose the intervals that are less than 0, which means I'm going to use my negative intervals. So this represents one of my answers right here, and going left forever. And then this represents another one of my intervals. So I'm going to say that the solutions are anything from -infinity to -2, and anything from 1 to 3. So this would be the interval notation. If you feel weird using interval notation because you just solved for x, you could say that x is less than -2, or x is in between 1 and 3. If you want to say, like, my solutions for x are this. Okay, let's try another example. So let's say we had a problem like x squared times x minus 2 over x squared minus 1, and we'll say this needs to be greater than or equal to 0. So this one is almost in the form that we want it to be in, but it's not quite factored. I want for it to be factored because I want to know what my x-intercepts are and what my vertical asymptotes are and what my holes are. So I'm going to go ahead and factor this completely. The bottom was difference of squares. And so I know that I have, there's no holes in this graph, but I do have a vertical asymptote at -1. And I do have a vertical asymptote at +1, and so I know for sure that on my number line, I cannot equal those numbers. I do have x-intercepts at 0 and 2, and based on the sign, you can equal 0, and so you're going to include x-intercepts. So if I draw my number line, I'm going to exclude -1, and I'm going to exclude +1, but 0 gets to be included, and so does 2. All right, so the difference between this problem and the last problem is that this problem says greater than or equal to 0. And so that means I can include the x-intercepts, the things that made the top 0. Okay, so just like before, now I'm going to take this factored form right here, and I'm going to plug different values in from each interval. So a number to the left of -1 would be like -2. So -2 squared, anything squared, is positive. -2 minus 2 is negative. -2 plus 1 is negative. I guess I didn't mean that parenthesis. And then -2 minus 1 is also negative. So these negatives on the bottom would cancel out and make a positive. And these would multiply to be a negative. So we have negative divided by positive, which is negative. All right, next I'll go ahead and plug in -1/2. So a negative times a negative is positive always. -1/2 minus 2 is negative. -1/2 plus 1 is positive. -1/2 minus 1 is negative. So here these negatives would cancel out, and then that overall would equal a positive. Next I can plug in +1/2. So that would be positive. 1/2 minus 2 is negative. 1/2 plus 1 is positive. 1/2 minus 1 is negative. So that does the same thing as the last one. That means that is positive. And then last we can do 1/2. So positive for the first one. 1/2 minus 2 is negative. 1/2 plus 1 is positive. 1/2 minus 1 is positive. And so this overall would be a negative on the top divided by a positive on the bottom, which is negative. And then last but not least, plug in 3, positive. 3 minus 2 is positive. 3 plus 1 is positive. 3 minus 1 is positive. Okay, so now we have to consider our inequality sign. Our inequality sign says we want things that are bigger than or equal to 0. So the ones that are equal to 0 are right here, and the ones that are greater than 0 are these positives. So you're not going to say, oh, every time I use the minuses or every time I use the pluses. You're going to use the ones that make sense for the inequality. All right, so I'm going to say that my first interval as my answer would be from -1 to +1. I don't have to stop at 0, it goes right through it. So I'm just going to say from -1 to +1, and from 2 to infinity. 2 gets a bracket. 2 to infinity. Or if I wanted to write this with x's, I could say x is between -1 and 1, or x is greater than or equal to 2. All those x values would work to make that inequality true. Okay, let's go ahead and try another one. So here we'll say x plus 4 over x minus 2 is less than or equal to 1. So this one does not look like we want it to look. So that means that the first thing we have to do is get everything to one side and make the problem equal 0. And this is where people can do the problems a little bit differently. You could take this fraction and minus it over to the right side and then have 0 over here. Or you could have the 1 and minus it over to the left side and have the 0 over here. You're going to get the same answer either way, but your work would look a little bit different and your sign chart would be a little bit different. So what I'm going to go ahead and do, and this is what I typically do in the problems, is I'm just going to minus the 1 over here. So if you want your answers to be easier to check, you might choose to do the same thing as me. All right. So now I need to change this, right? I have a subtraction problem with two fractions, and so that means I need a common denominator. And so I'm going to think of this 1 as like 1 over 1. And so that means that my common denominator for this problem would be x minus 2. So I need to multiply the top by x minus 2 and the bottom by x minus 2. And so that means that I have x plus 4 minus x minus 2 all over this common denominator. And you'll notice I'm being careful to show all my work with my subtraction because I want to make sure that I distribute this negative when I do the problem. So I have x plus 4 minus x plus 2. And so my x's cancel out and I just get 6 over x minus 2. So this problem actually ended up being pretty simple. So on the bottom that shows me I have a vertical asymptote at 2. And I can't have my vertical asymptotes. The top, there's no x there, so that tells me there's no x-intercepts. So I don't even have to worry about whether or not to include a number for the top because there's nothing to include. So do not use the 2. So now I'm going to choose a number on either side to see which side we can use. So I could plug in 0. If I plug in 0, I get a positive for 6, right? That's positive. 0 minus 2 is negative, and so this interval would be a negative. A number to the right of 2 would be like 3. Again, 6 is positive. 3 minus 2 is positive. And so this interval over here is positive. So if I think about the inequality says this stuff needs to be less than 0. And so that's going to use this interval over here as the answer. And so I'm going to say that my interval is from -infinity to 2. Or I could say x needs to be less than 2 to make the inequality true. Okay, let's try one more. So we're going to do 1 over x minus 2 is less than 2 over 3x minus 9. So again, just like before, we need one of the sides to be 0. So I'm going to write 1 over x minus 2 is, I'm not going to write the problem again, that's silly, minus 2 over 3x minus 9 is less than 0. And so I need to go ahead and get a common denominator for this problem, and the common denominator is going to have each of these things in it. And so my first fraction needs to multiply by 3x minus 9 on the top and the bottom. And my second fraction needs to multiply by x minus 2 on the top and the bottom. And so if I write this, I'm going to have 3x minus 9 and x minus 2 as my common denominator. And then 3x minus 9 times 1 is just 3x minus 9. And I am subtracting off what I get from this stuff. So I'm subtracting off 2x minus 4 is what I will be subtracting off. All right. So let's simplify this. This is less than 0 and see what we have. So I've got 3x minus 9 minus 2x plus 4. And so that leaves me with x minus 5. And then this is x minus 2. And if you look at this, you can technically factor that. There's a GCF of 3 in there. So I'm going to go ahead and take out that GCF of 3 and write down what my leftovers are. So my leftovers should be x minus 3. Okay, so that means that for this problem, I have an x-intercept of 5. And I have 2 vertical asymptotes, one at 3, one at 2. So x for sure cannot equal 3, x for sure cannot equal 2. And then to see if x can equal 5, we have to think about the problem and the sign of the inequality. So if you look at the inequality, you can see that you are not allowed to equal 0. And if I plug in 5, I would equal 0. So I'm going to say does not equal 0, so exclude the x-intercepts. Okay, so let's go ahead and do the part of the problem where we use our number line. So my number line is going to have a 2, a 3, and a 5. So the 2 I can't have, the 3 I can't have, and the 5 I can't have. Okay, so if I choose a number that's to the left of 2, that's like the number 1. And so if I think about 1, I would have 1 minus 5 is negative, divided by 3, which is positive. 1 minus 3 is negative. 1 minus 2 is negative. So on the bottom, that would be positive. A negative divided by a positive is negative. All right. A number between 2 and 3 would be like 2.5. So 2.5 minus 5 is negative. 3 is positive. 2.5 minus 3 is negative. 2.5 minus 2 is positive. Those negatives would cancel out, and so this would be a positive interval. A number between 3 and 5 would be like 4. 4 minus 5 is negative. The 3 is positive. 4 minus 3 is positive. 4 minus 2 is positive. So that's going to be a negative interval. And then the number to the right of 5 is like 6. 6 minus 5 is positive. The 3 is positive. 6 minus 3 is positive. 6 minus 2 is positive. So that interval is definitely positive. All right, so we are choosing the intervals that are less than 0. And so that means that we are choosing this interval right here and this interval right here. So our solution to the inequality is going to be from negative infinity to 2 and from 3 to 5. Or you could say x is less than 2 or between 3 and 5.